Good day, students. Welcome to mathgotserved.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 1 to 5 of the 2016 Algebra 1 Staar exam. Alright, let's take a look at question number 1. Question 1 reads, a savings account balance can be modeled by the graph of the linear function shown on the grid. So we have the graph here of the savings account balance. Question, what is the rate of change of the balance with respect to the number of deposits? Alright, so what we're going to do first is we're going to start by writing down what the formula for computing the rate of change is. Okay, so let's write down the formula. Formula for rate of change. So the rate of change on an interval, let's say you're going from x1 to x2. So rate of change on an interval x1 to x2 is basically the slope of the line that goes through the point containing x1 and x2. And how do you compute the slope? The slope is simply rise over run. So in this particular problem, we can compute the slope graphically by picking 2 points that fall on the line and are also lattice points, and then just determine the rise over run. Or we can compute the slope numerically by determining the coordinates of 2 points, x1, y1 and x2, y2, and computing the quotient of y2 minus y1 divided by x2 minus x1. Okay, so you can use any of these two methods to solve this particular problem. Now what I'm going to do is I'm going to pick 2 points that I'll use to compute the slope, and I'll do this numerically. Okay, so let's call this point 1 and this is point 2. So point 1 is 0, 50, and then point 2 is 1, 150. Okay, so point 1 basically helps me determine x1 and y1, and then point 2 helps me determine x2 and y2. Okay, now the slope, let's write this down, or the rate of change, let's change the color here. The rate of change let's say on going from point 050, point P1, so the rate of change on 050 to 1, 150 is basically y2 minus y1. That's the rise divided by x2 minus x1, which is the run. Okay, and this is basically the slope. So let's compute the rise. The rise is y2, which is 150, minus y1, which is 50, divided by the run, x2, which is 1, minus x1, which is 0. 150 minus 50 is 100, over 1, which is just 100. Okay, it says $100 per deposit. So our answer for question 1 is option letter A. Alright, let's take a look at question 2. Question 2 asks, which expression is equivalent to 2x squared plus the quantity 4x minus 6x squared plus 9 minus the quantity 6x plus 3? Alright, so something to keep in mind, a common mistake most students make when distributing has to do with the minus in front of the parenthesis. So you have a minus in front of this parenthesis, so you want to proceed with caution. Okay, so the caution here is do not forget to distribute the negative to all terms in the parentheses. Okay, so one big mistake that most students do is they distribute the negative just to one term. Okay, so like you distribute the minus to just the 6x and forget about the positive 3, and that's incorrect. So make sure you distribute it to everything. All right, so let's go ahead and solve the problem. We have 2x squared plus the quantity 4x minus 6x squared plus 9 minus 6x plus 3. Now here, imagine that there's an invisible one. Okay, it's a multiplicative identity, so we don't have to write it there. Okay, so what we're doing is we're going to distribute this positive 1 to the 4x and 6x squared. When you carry out that distribution, nothing happens. As indicated earlier, 1 is a multiplicative identity in the sense that when you distribute 1 to any number, you end up with exactly what you started with. Okay? But here we have negative 1, so the situation is different. So what we're going to do is distribute this 1 and a negative sign to both terms in the parentheses as indicated earlier. When we distribute negative 1 times positive 6, you have negative 6x minus times plus is minus. Remember, anytime you multiply signs that are different, the resulting sign is always a minus. Alright? Okay, so we have the distribution taken care of. We're now going to proceed to combine like terms. Let's start with the highest power, which is 2. So we have two terms that are of the second degree, 2x squared and negative 6x squared. Since your signs are different, we're going to subtract and keep the sign of the bigger. Okay, so we'll subtract 6 minus 2 is 4x squared. The bigger of the two is negative, so we preserve the negativity. Now let's go to the first degree terms, which are the 4x and negative 6x. When we combine those two, plus 4x minus 6x, you subtract again and keep the sign of the bigger, so negative 2x will be your answer. And then to finish this off, we'll proceed to the 0th degree term, also known as your constant. Okay, so we're going to combine positive 9x with negative 3. Subtract and keep the sign of the bigger. We end up with positive 6 as our final result. Okay, so this expression here is equivalent to negative 4x squared minus 2x plus 6. So we can clearly see that our answer for this question is option letter G. Alright, let's take a look at question number 3. It reads, baseball fans can buy tickets for seats in the lower deck or upper deck of the stadium. Tickets for the lower deck cost $42 each. Tickets prices for the upper deck are 75% off the cost of the tickets for the lower deck. Which inequality represents all possible combinations of x, the number of tickets for the lower deck, and y, the number of tickets for the upper deck that someone can buy for no more than $800. So before we go ahead and set up the equations, let's write down the formulas that will be guiding the problem solving process. Okay, we have two sets of formulas here. The first one has to do with total cost. So how do you compute the total cost of a certain number of items? All you just have to do is you multiply the unit price. You multiply the unit price by the quantity. Okay. Secondly, we need the formula for calculating the percent discount. In this particular problem, the upper deck tickets were 75% off the cost of the lower deck tickets. So percent discount is basically the percent off divided by 100 to convert it into decimal form or fractional form, multiplied by the original price. Okay. Alright, so just a real quick addition. This is percent discount price. Okay. All right, now we're going to start by determining what the percent discount price is. Basically, the unit price for the upper deck, okay, because we needed to set up the cost for the upper deck tickets. All right, so let's go ahead and compute that first. So the unit price of the upper deck tickets um, is 75% of the lower. Alright, so with that in mind, we can simply determine what the unit price is by calculating 75 over 100 multiplied by 42. Alright, so let's go ahead and multiply that with our graphing calculators. So we're going to have 75 over 100, which is the same thing as 0.5. 75 divided by 100 multiplied by 42. And we have 31.5 as the unit price for the upper deck. Okay, so we have 31.5. Alright, so we're ready to set up our inequality. Okay, so what are we looking at here? We're looking at the costs to not exceed 800. So this is basically like a maximum or a ceiling price. Okay, so if you have a maximum or a ceiling price, the inequality that we're going to be looking at is something that's equal to or less. Okay, so if it's no more, it could be equal to or less. All right, so for a maximum cost of $800, we have the following setup. We should ensure that the cost of upper and lower should be less than or equal to 800. Okay, so cost of how many lower tickets, lower seat tickets are we buying? We're buying X, right? So cost of X lower tickets plus the cost of Y number of upper seat tickets has to be no more than 800, or basically less than or equal to 800. Okay, so how do you compute the cost of X lower tickets? What you do is you just take the unit price of the lower seat tickets unit price of lower, and you multiply that by the number of tickets for the lower seats, which is X. Alright, and then for cost of upper tickets, you look at the unit price for the upper seat tickets, and then you multiply it by the total number of tickets for the upper seats, which is Y. And then this combined cost should be no more than 800, or less than or equal to 800, mean exactly the same thing. Okay, alright, so let's go ahead and substitute the values in. So the unit price for the lower seat tickets is provided to us. It's $42 each. You multiply that by X. This is for the total costs for X lower seat tickets. For the Y upper seat tickets, the total cost is going to be the unit price, which is 75% of 42. We calculated that to be 31.5. That's the unit price, times the number of tickets, which is Y, and this should be less than or equal to 800, or no more than the constraint of $800. Okay, so this is the inequality that represents the situation. Our answer is option letter B. All right, let's take a look at question number 4. It reads, function p is in the form y equals ax squared plus c. If the values of a and c are both less than 0, which graph could represent function p? Alright, so let's go ahead and talk a little bit about what kind of function this is and the kind of transformations that are applicable here. Okay, so we have to remember our transformation rules. In this particular case, we are focusing on the transformations for y equals ax squared plus c. This is the function for a parabola that has been shifted vertically and has been it could have been shifted vertically and has undergone a reflection in the vertical direction also. Okay, so if you take a look at your options right here, you notice that they're all parabolas that have undergone some kind of vertical translation, and then some of them have been reflected and some of them have not been reflected. So what's the rule for a parabola that's of this form? Just by altering the signs of a and c, if they're non-zero, then we're going to have some transformations happening. So if a is less than 0, what does that tell us? It tells us that the parabola is going to be opening downwards. Okay, so less than 0 implies that a is negative, so negativity is just like sadness, so the parabola is sad or opening down. Okay, if a is greater than 0, basically a is positive, it tells us that the parabola is happy. It opens in the upward direction, so we have a happy parabola. Okay, so that's one of the transformational impacts that a has. Okay, a also causes dilations to happen, but in this particular case, we're just focusing on reflections. Now, what about c? If c is less than 0, what happens is that we're going to have a shift in the vertical direction. Since it's negative, the shift is going to be downwards by that c value. So let's say you have your coordinate system like this. The parabola is going to be shifted downwards depending on the opening. Okay. If c is greater than 0, that involves shifting the parabola upwards by c value. Okay, so if you have an upward opening parabola, for example, if you shifted c units up, the vertex ends up above the x-axis. Okay, so in this particular case, a and c are both negative. So since a and c are negative or are less than 0, what does that tell us? We're looking at this scenario right here, less than 0, opening downwards, and this scenario right here, shifted down. So we have a situation where the parabola opens down, okay, and it is shifted down. So what we're doing is we're looking for a parabola that opens downwards and the vertex has been shifted downwards too. So let's ID our vertices. So that's the vertex of option F, G, H, and J. So which one opens down? F, H, and J opens down, so we can eliminate G. Okay, now we're going to look at the position of the parabola. Which one has been shifted downwards? Which one is beneath the x-axis? Okay, this is above, so no. This is beneath, this is excellent. So we see the answer is option H. Take a look at J. It's right on the origin, which indicates that C is equal to 0. There are no shifts here, which makes this an incorrect option. Alright, let's go ahead and take a look at question number 5. It reads, the table represents some points on the graph of the linear function, So we have a graph here, a table here. So question is, which function represents the same relationship? Now this is a little bit tricky because some students might take a look at this 0, they might gravitate towards the 0, and they might say, oh, the y-intercept is negative 3.5 since when y is 0 we have an x value of negative 3.5. But is that the case? Now this is something very important that you want to keep in mind. It has to do with what the y-intercept is. Okay, so let's note the following point. Note for the y-intercept, x has to be equal to 0. Okay? So if you take a look at this ordered pair right here, is this an x-intercept scenario? The answer is no. Okay? This is not the y-intercept. Because remember, the y-intercept is a b value. So you have a b here of negative 3.5 and a b here of negative 3.5. That's not the case. We can't use that because x is not 0. It is y that is 0. So this is an x-intercept, not a y-intercept. Okay? So let's keep that in mind. To help us answer this question, what we're going to do is pick an ordered pair and see which equation satisfies that ordered pair. Okay, so let's go ahead and just pick negative 1 and negative 7.5. So we're going to test the ordered pair where x is equal to negative 1 and h of negative 1 is equal to the y value, which is negative 7.5. So if more than one function satisfies this coordinate pair, we will then move on to another point. Okay, eventually we'll end up with only one that satisfies multiple test values. So let's try this one first. If we get only one that works, then we will be done. Okay, let's start with option A. So for option A, we have h of x equals negative 3x minus 10.5. So what is h of negative 1 going to be? You're going to plug in negative 1 into this function. So you have negative 3 times negative 1 minus 10.5. Multiply this out. You have 3 minus 10.5. And your final answer is going to be negative 7.5. You can do that with your calculator, which is excellent. That's what we're looking for. Alright, let's test option B. Let's see what happens there. H of negative 1 is going to be negative 1 minus 3.5. If you simplify this, you have 1 minus 3.5. 1 minus 3.5 is negative 2.5. And that is not the y coordinate we desire, so this is incorrect. Scratch out option B. Option C, let's see if that works. H of negative 1 is going to be 3 times negative 1 minus 10.5. Okay, we're going to have negative 3 minus 10.5, which is negative 13.5. This one is a fail also. It's not an answer. Let's go ahead and try option D. So for option D, we have h of negative 1, which is negative 1 minus 3.5, which is negative 4.5, and that is not negative 7.5. So this doesn't work. So just by testing this coordinate pair, we found out that only one works, and it's the correct answer, which is option letter A. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming STAR exam, do give us a thumbs up. Your positive feedback will be greatly appreciated. If you have any questions about the contents of this presentation or any math concepts on the STAR test in general, just place your questions in the comment section below and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other tutorials such as this. More clips can be found on mathgotserved.com under tests prep. Thanks again for watching and have a wonderful day. Goodbye.